recommended daily potassium intake for an adult is roughly 4,000 milligrams. One banana contains 422 milligrams of potassium, and one egg contains 63 milligrams of potassium. Which of the following inequalities represents the possible number of bananas B and eggs E an adult could have daily to meet the recommended daily potassium intake from these foods alone? All right, so a lot to unpack there, but I'm just going to move this over a little bit. So we have a couple of different answers to choose from. Some of these we can just strike out right off the bat. For instance, we're looking for the minimum number of eggs and bananas we'd eat to reach 4,000 milligrams. So since this number 3 is less than 4,000, it doesn't make sense, right? And then another one, number 2, doesn't make sense either because we're we're messing up the variables here. So we have, 422E doesn't make sense because it should really be 422B for bananas, and 63B doesn't make sense because this applies to the eggs, which should be E, so we can just get rid of that. The last two possible solutions are 1 or 4. Now 4 doesn't make sense because it's just kind of messing up the operations. We shouldn't be dividing here, we should be multiplying. We're asking how many bananas or eggs does it take to reach 4,000, not, how many. I don't even know what this would be actually, so we can kind of just get rid of that. So we know that the answer is 1. And of course this makes sense because, we're looking for the minimum number of bananas, B, and eggs, E, that it would take to reach 4,000 milligrams at least. So that's our solution. The teaching assistant randomly selects 40 undergrad students from all students enrolled in a math program at their university. He asks each of the students, how many minutes each day do you usually study? The mean study time in this sample is 104 minutes, and the margin of error is 3.64 minutes. Another assistant decides to reproduce the survey and will try to get a smaller margin of error. Which of the following samples are most likely to result in a smaller margin of error for the estimated mean time students in this math program study daily? So for this one, we just need to understand how we would get a smaller margin of error. Typically, this is done by increasing the sample size. If we have a smaller sample, then you figure if you have one outlier among 5 people, then that's going to really affect the average study time. Whereas if you have 100 people and one outlier, it's not going to affect it that much. Even if you have 5 outliers, it still won't affect it as much as one person. One outlier would affect 10 people. So for this one, we're going to be looking at number 3 and number 1, really, because these are the biggest ones. We can just cross out number 4 since it's a much smaller group, and the same with number 2. So now the question really is just which one do you pick, number 1 or number 3? So in this one, we're going to choose number 1, and the reason for that is that it's most relevant. We're selecting them from undergrad math students, whereas number 3, even though it has a larger sample size, we're selecting them from all programs. So it's not going to be as specific to what we're looking at, which means that number 1 is our solution. And really just trying to solve these problems is a matter of thinking about trying to increase the sample size and trying to keep it relevant. At a zoo, the mean age of all female giraffes is 12 years, and the mean age of all males is 15 years. Which of the following must be true about the mean age A of the combined group of male and female giraffes at the zoo? Okay, so this is actually a proper math problem. It's not like an SAT problem, really. So we just need to think about, what could be true about the mean age A of the combined group? What could we say about it? So question 1, or solution 1 rather, we're saying that A is less than 12. Well, does this make sense? No, this doesn't make sense because the mean age of all males is 15 years, so it must be at least greater than 12, right? A needs to be at least greater than 12, so we can cross that out. So solution 2, age is greater than 15. Well, this can't be true either because the mean age of all males is 15 years, so it needs to be at least less than 15 years is... and we know that because also the mean age of all female giraffes is 12 years. So these 15 and 12 need to combine somehow, and they're going to produce an answer that's less than 15. So we know that this is wrong as well. Number 3, 12 is less than A, which is less than 15. We're saying that the mean age A should be somewhere between 12 and 15. So this is the right answer, and we can see that because the lowest average age is 12 and the highest average age is 15. So we know that the mean age A should be somewhere in between those two numbers. We know that number 4 can't be right also because we don't know, even though 13.5 is between 12 and 15, we don't know that there are an average or an exact number of female giraffes to male giraffes, and we don't know that it averages out to be exactly 13.5.